Thanks for tuning in at Brackeys.
Hello and welcome to the second video on creating a multiplayer FPS in Unity. Today we finish what we started in the last video, which is creating the character controls for our player. So if you haven't watched that yet, I recommend you do so by clicking the screen now. And if you have, well, enjoy! So now we can jump over to our player mode and actually make this happen. So if we look over here, we are going to have a private vector3 called velocity, and we're going to just default this to vector3.0. You can just leave this, that's what it's going to default to anyways. And we're also going to have some kind of private reference to our rigid body. So rigid body, and we'll just call this RB. Then in our start method, just as before, just as we did with the player motor, we can say RB equals get component and of type rigid body. And again, we are requiring the component up here, so that's completely legit. And then here we can make some kind of method for setting our velocity variable. Because basically what we want to do is we want to have this player controller control this variable. And then we want to have a fixed update loop here that uses this variable to move the player. So the kind of method that we want to control this variable is simply going to be called move, and it takes in a vector3 velocity, and I'm using underscore velocity here, and this is why it's important, because we want to differentiate between this velocity and this velocity. And then we simply say that we want velocity to be equal to the velocity passed in. So this here takes or gets a movement vector, and then we want to have some kind of fixed update loop, void fixed update, run every physics iteration. So this runs on a fixed time, and basically we want in here to perform our movement. So we want to call some kind of method that will actually do this movement. So let's create that now. So perform movement based on velocity variable, and we'll just make this a private method. So void perform movement. And this is going to check if velocity is not equal to vector3.0. So if we actually want to move, well, then we want to set, or then we want to say that we can call a method called move position on our rigid body. And this is a super useful method. This takes in the position that we want to move to. And this is different from transform.translate, because this will actually stop the rigid body from moving there if it collides with something on the way. So this does all of the physics checks and the collision checks and all that, but is much easier to control than the add force method. So in here we want to pass in our current position, so we could either say transform.position or rigidbody.position. That's going to be completely the same. And then we want to add on to that our velocity multiplied with time.fixed delta time. And we'll just close that off. So this will move our rigid body, our player, to the position of our player plus the velocity vector. So that actually performs the movement, and that's all we have to do in order to get this working. So let's go ahead and try this out now, and we should be able to move in the game. So let's hit play. And you can see that we are indeed now moving. We can't jump and we can't look around, but that's a start, of course. Okay, so next up, we want to have some kind of rotation. So in our player controller, we want to now calculate calculate rotation as a 3D vector. And we do this by first getting some input. So y rotation is going to be equal to input.getAxis raw. And this is very similar to what we were doing up here. And the input that we want to get is called mouse x. And you want to, of course, spell this completely as I've done here. Remember the space, remember the capital M and X. And again, that's something set up in the Unity input section. And then we want to create a vector here, which is going to store our rotation. And it's going to be equal to a new vector. And it's going to be 0, comma, y rotation, comma, 0. And we'll multiply this by some kind of sensitivity variable. So we, just like we have the speed up here, we also want some kind of look speed or mouse sensitivity or whatever you want to call this. I'm going to make this a private float called look sensitivity. And we'll just default that to, I don't know, 3. Cool. So we'll simply multiply that down here, look times look sensitivity. So you will notice here that I'm only using our Y rotation, which will be when we move our mouse to left or to the right side. And that means our X value from the mouse. So that's kind of weird when you think about it. But when we move our mouse on the X, we want to rotate around the Y. And I'm only doing this here because the Y rotation is the only thing we want to affect our player. The rotation around the x-axis, meaning tilting up and down, well, that's something we want to only affect our camera. Because we don't want the entire sphere to rotate up and down. That would mess up our movement. So when doing this, know that this is just for turning. So calculate rotation as a 3D vector, and we could just say this applies, or let's just do this, turning around. That's what we're doing here. And then we want to apply this. So we want to apply camera rotation. Not camera rotation, we want to apply rotation. I was thinking about the camera now. And we simply do motor.rotate. And this is another method that we're going to be creating. So, and we then pass in the rotation vector there. And let's go ahead and create that in the character motor now, or the player motor. And in here, we then want to go up and make a variable. And we call this we make this a private vector3, again called rotation, and we'll default it to vector3.0. And then we want to make some kind of a method that will change this. So that's the rotate method. And we'll take in a rotation. And we'll simply set rotation equal to underscore rotation. And this gets a rotational vector there. And then in the fixed update, we want to actually perform the rotation. And we do this by creating a new method, of course. So we want to perform rotation, void perform rotation. This doesn't take in any arguments, just like our perform movement method. And we simply want to say rb.moveRotation. And whenever it comes to rotation, there are some weird stuff, basically. Because rotations in Unity goes through what is called a quaternion system, if you will. So quaternions are basically just like vector 3s, but with an imaginary component. And what this means, I will leave to a mathematician to explain, because quaternions are quite difficult to understand. But we, of course, have some really cool functions in Unity that takes care of all of this weird calculation stuff for us. So just like when we are moving our player, we want to get our rotation. Just like here we get our position and we add on the velocity. Well, here we get our rotation and then we add on, or we multiply that with quaternion. This is what I'm talking about, quaternion dot Euler. And Euler angles are the angles that we know. That's the X, Y, and Z rotation. It takes in a simple vector 3. So in here we can simply input our rotation. So rb.rotation is a quaternion, and quaternion.Euler will take in our vector 3 and make it into a quaternion. So that makes sure that we don't have to understand what's going on. We can simply do this calculation. And that's really awesome. So let's simply save that now. Head into Unity here, and we should be able to look around on the x-axis or around the y-axis. So now we can actually walk around, but we can't really aim. So let's make the tilting of the camera. Let's go back in here, find our player controller, and add another segment. So this one is going to be calculating camera rotation. So I'm just going to duplicate this entire section, and we'll just call this calculate camera rotation as a 3D vector. And this is not going to be y rod, but instead be it's going to be x rod, and it's going to equal get axis raw of mouse y now. And this is not going to be called rotation, but camera rotation. And it's not going to rotate around the y, but instead rotate around the x. And then we apply it by using another function, which is going to be called rotate camera. And we're going to input our camera rotation instead of the rotation there. So apply camera rotation. So this is again around the x-axis. And then we jump into the player motor, and you are of course starting to notice a pattern here. So we then create a private private vector 3 camera rotation equals vector 3.0. We jump down here and create a method for gets a rotation of the vector for the camera. Rotate camera, and it's going to take in a rotation, or you could call this a camera rotation, and it's simply going to set camera rotation equal to underscore camera rotation, just like we've done with all of the other methods. And then down here, when we perform the rotation, we can do this in the same function call. We of course want to apply this to the camera, so we need a reference to our camera. And even better, we can make this reference optional. So if we don't have a camera that we want to be controlled, we can make a game that only moves around the Y or rotates around the Y. Lots of games have a fixed tilt, if you will, and only allows you to turn. So let's just make this optional. First off, we want to create this reference, and again, I want to use a serialized field, private camera, and we'll just name this cam. You won't be able to name this camera because that's a method, or that's a member that is included in mono behavior. So we have the cam, and then down here we can simply check if cam is not equal to null, meaning we've put in a camera. Well, then we want to say that cam.transform.rotate. So here we don't need to do any rigid body calculation. We can simply rotate using the transform.rotate method. And how do we want to rotate? We want to rotate using camera rotation. And this might be in the wrong direction, so we'll check this. Now I am, of course we need to put in the camera here, player. And you can see we didn't get an error here, just nothing happened really. So that makes it optional. So we want to drag in our camera and now hit play. And now I'm moving up and I'm moving down. So you can see that's inwards. So the only thing we need to do to fix this is simply put a small minus there. That will make this the opposite vector. So that will inverse it. And now we can look around just like we want to. So that feels pretty nice actually. And you can of course adjust both your movement speed. Ooh, this is fast. And your look sensitivity even while the game is running. Cool. So that's the very base of our movement. And I think I'm going to leave the tutorial here. Then we'll create all of the spring functionality and the flying stuff in a later video, just so this won't get crazy long. So this was already a really long tutorial, and I've probably also have to split it up into 2 parts. But I hope you enjoyed it and that you were able to follow along. If you have any great suggestions for where this series might go and what you want to see in this course, well then of course leave them down below or on the Brackeys forum. And again, thanks for watching, and I'll see you in the next video.